1.3 complex numbers. So the number I is defined such that I is equal to the square root of -1, and I squared is equal to -1. A complex number is a number of the form a plus bi, where a and b are real numbers. The number a is said to be the real part of a plus bi, where the number b is said to be the imaginary part. Keep in mind that's because b is being multiplied by I, which by definition I is the imaginary number. Now addition and subtraction with complex numbers obey the same commutative, associative, and distributive laws as we dealt with when we dealt with binomials. So we collect the real parts and the imaginary parts of complex numbers, just as we collect like terms in binomials. Right, so this first example says to simplify and write your answer in the a plus bi form, where a and b are real numbers. So let's get started with that one. The first thing I need to do is rewrite this square root of -64 and this square root of -9 in terms of I. Now recall that the square root of -1 is I. So where I have the square root of -64, that's the same thing as saying the square root of 64 times the square root of -1. Square root of 64 is 8. Square root of -1 is I. So you should remember this portion right here from intermediate algebra when you dealt with imaginary numbers. All right, so what that means here is I've got 6 minus 8i plus 4 plus, now square root of -9 would be 3i. All right, so now what you're doing is you're going to combine your like terms. So if I look, that means I'm going to combine the 6 and 4. So it would be 6 plus 4. This would be the real part. Plus, now I'm going to take the imaginary part and combine those. So that's the -8i plus 3i. Now you can write it in several different ways. You could just look at the coefficient in front, so the -8 plus 3, and then have your I on the outside, or you could have written -8i plus 3i. You get the same answer either way. All right, so combining my like terms, I have 6 plus 4. That gives me 10. Now, plus -8 plus 3, that gives me minus 5i, because it gets multiplied by the I. Now, it is very important that you put your answer in that a plus bi form, that you write it as 10 minus 5i. If you write -5i plus 10, MyMathLab will mark you wrong because you will have not put it in the format that it requested as a plus bi. All right, now just like we had to be careful with subtraction with binomials, we need to do the same thing here. We need to distribute this negative to each term. So you can think of that minus sign as a -1 out in front that you have to distribute to each one. So that gives me 14 plus 9i minus 3 minus 3i. Once again, you're going to combine your like terms. So I'm going to group my real parts together. So that would be the 14 and the -3. So I've got 14 plus a -3. Plus, now I'm going to take the imaginary part and group that together. And that would be the 9 minus 3i. That's from the 9i and the -3i. So 14 plus a -3, in other words, 14 minus 3 gives me 11. plus 9 minus 3, so 6i. So that leaves me with 11 plus 6i. Now moving on to multiplication. So when we're dealing with multiplication, you want to multiply square roots of negative real numbers. We first express them in terms of I. So very important, you don't want to leave it as the square root of negative 3 or the square root of any type of negative number. You want to always write it in terms of I before. Now, if you're just dealing with a positive square root, you can go ahead and multiply that out. But if you've got, for example, the square root of negative 5, you would rewrite that as the square root of 5i. Now, for this first example, we're not dealing with any imaginary numbers or the square root of a negative number. So we can just simply FOIL this out. Alright, so the instructions say simplify, write your answer in a plus bi form, where a and b are real numbers. So looking at the first one, I have 6 plus the square root of 5, and I'm squaring that quantity. You need to be very careful here. This is where a lot of people make a mistake. What I always recommend doing is writing it out. So I've got 6 plus the square root of 5. Now if it's squared, that means it's being multiplied by 6 plus the square root of 5. So go ahead and FOIL that out. That gives me 6 times 6, which is 36, plus 6 times the square root of 5, so plus 6 square root of 5. Then I take the square root of 5 times 6, so plus 6 square root of 5 again. And then square root of 5 times square root of 5 just simply leaves me with 5. Alright, so now I'm going to combine my like terms. I've got 36 and 5 that I can combine together. That gives me 41 plus, now 6 square root of 5 plus 6 square root of 5 gives me 12 square root of 5. And so I'm done with that problem. Note that there are no imaginary parts to this one because I wasn't taking the square root of a negative number and I didn't have I, imaginary number. Now this is different than the next problem where we're given two binomials, both with imaginary parts to them. Alright, so when I work through this problem, once again, I'm going to FOIL. So I'm going to take that negative 4 and I'm going to multiply it by 5. That gives me negative 20. Negative 4 times negative 6i gives me a positive 24i. Now I'll take negative 3 and multiply it by 5. That gives me negative 15i. And then negative 3i times negative 6i gives me a positive 18i squared. Now first things first, we want to get rid of that I squared. Recall that by definition, I squared is equal to negative 1. So what that means is I've got negative 20 plus 24i minus 15i plus 18 times the negative 1. Alright, so you can combine your like terms here. Combine that 24i minus 15i, and that'll give you negative 20 plus 9i minus 18. Notice that it became minus 18 because 18 plus 18 times the negative 1 makes that a negative 18. Alright, so now you can combine those two like terms, that negative 20 and that negative 18, and that gives you negative 38 plus 9i. Once again, make sure that you put it in that a plus bi form. Alright, the last thing we're going to look at in regards to complex numbers is division with complex numbers. So, some things you need to be aware of before we can do this division is that the conjugate of a complex number a plus bi is a minus bi. So all you do is you just change whatever this symbol is. So the complex conjugate of a minus bi is a plus bi. Now, conjugates are used when we divide complex numbers. So we multiply the numerator and denominator by the complex conjugate of the denominator. Alright, so what's that going to mean for this example? We want to simplify and we want to write our answer in a plus bi form. So I've got 2 minus 3i over 5 plus 7i. Now recall, I'm going to multiply both the numerator and denominator by the complex conjugate of the denominator. The whole idea of why we do that is because it'll get rid of the imaginary number in the denominator. Alright, so what I'm going to do is I'm going to multiply by 5 minus 7i over 5 minus 7i. Note that I switched the sign from positive to negative and I put it on both. Alright, so at this point we need to FOIL. Alright, so I've got 2 times 5, which gives me 10. Then I take 2 times negative 7i, which gives me negative 14i. Negative 3i times 5 gives me negative 15i. Negative 3i times negative 7i gives me positive 21i squared. Now note that this is all over. Now here you should see that you've got a difference of squares, but if you don't, you just go ahead and FOIL it out. So I'm going to show it FOILed out for those people that don't see the difference of squares right away. Alright, so I take 5 times 5, which gives me 25. And then I have 5 times negative 7i, so that gives me negative 35i. 7i times 5 gives me a positive 35i. And then 7i times negative 7i gives me negative 49i squared. So this is what we're talking about with the difference of squares, that we knew that these were going to cancel out. Alright, so now what I'm going to do is I am going to combine my like terms where possible and rewrite the I squared as negative 1. So in the numerator, that gives me 10 minus 29i plus 21 times negative 1 over 25 minus 49 times negative 1. Alright, so that means I've got 10 minus 29i minus 21 over 25 plus 49. So that gives me negative 11 minus 29i over 74. Now, do not enter your answer this way. It wants it in a plus bi form. That's what the instructions asked for. So you have to rewrite this as negative 11 over 74 minus 29 over 74i. This is the a plus bi form and the correct way to submit your answer.